let's think about this weird example, which is all driving me nuts. Reclaim host. I don't care if I'm host or not. All right, so what are we doing here? This is an example where we know that there's some beta that's false. Oh no, that says all betas are false, and hence there exists a beta that's true is false, and hence we get this, and hence we get that. All right, so here we know this fact here, that this gives us this. We turn it around, right? So that we negate this guy, and we get that for all y beta is false. It gives us that for all y alpha is false, right? And then 2 is assuring us of this. So then we do modus ponens and we're done. That was the whole example. It was a little scary. It wasn't worth it. And I think we're behind. Let's not do the distributive law because I don't think it's that exciting. I think this one is more exciting. All right. Our friend is not here today, but somebody gave me this example, and I think it's a fun example. All right. All right, so let's see if we can understand what this is saying. All right, this is here we have either the x's, right, something in the inside, and we have for all x there exists the y versus there exists the y for all x. And you know that's the classic thing that I started with, everybody needs to learn, right? And this one, the x that exists, the y that exists can depend on the x, right? You give me a y, I get a different, you give me an x, I get a different y, right? Well, this one over here, is you need one y that works for every x. All right, they're different. So you look at this and you say, great, does the left side give me the right side? Right? If there's one y, is that, yeah, that one's true, right? What about the other direction, right? Classically, that's false, right? So when he showed it to me, I said, come on, that's not true. But see, everything's going. This button here is sticking. Why? Why are we having so many technical difficulties today? Distributive law, we're not doing distributive law. We're here. All right. All right. So it turns out that it's an if and only if here. And why is, anybody guess why it's an if and only if? Right? What's the difference between, it has to do with this inner bit, right? What's the difference between this guy and this guy? In fact, when I was sleeping last night, I suddenly realized something I should tell you about this example. Right? Let me draw it on the board quickly. Here, if this is alpha, we have x's and y's, right? How many entries do let's suppose I have n x's and n y's. How many each one of these is a true false? How many true falses do I have to give you? Right? They're n squared of them, right? But here I have alpha and I have beta, and each of them have n, right? So there's only 2n. So people in this world didn't see this, but to get this, you need n squared entries. Well, here you need n entries and n entries, right? So it's different. And what's different about it is that somehow they're separated, right? Which y works over here has nothing to do with x, right? And so it turns out that both of these statements are equivalent to this, right? It says there you can bring there exists an x for which alpha's there exists a y for which beta is true, and for all x alpha is true is separable into two different things, right? So that's good. And then we were trying to think about how to prove it, and we came up with well, there's an or, so we were doing a formal proof and proof by cases. And it was kind of, and then when I went home and it wasn't quite working, so I got up and managed it to work, but it was really kludgy. And then I thought, well, how would you do it by the game? And again, you need proof by cases, but it seemed prettier to me. You know, I like the game. So let's think about it here, right? So what we're claiming, at least, we don't know this yet, but we're claiming that both of these statements say either there exists a beta that's true, right? Or all the alphas are true, right? That's what we're thinking that this says. Everybody with me here? So, all right, I don't know what we're doing here. So what are we trying to do? We're trying to say she is going to assure us of the left-hand side, and we're going to want to prove the right-hand side. But I don't have the right-hand side written here yet, because what we're going to do now is focus on what can this oracle do for us, right? We go up to the top of the mountain, we have this oracle, and we're trying to understand what's true in the world, right? And what she can do is if I give her an X, she can give me a Y, right? And let's try to figure out whether that's a useful oracle or not, right? So what am I trying to do? Well, I'm trying to find a Y that's an alpha that's not true, or I'm trying to find a beta that is true, right? I mean, those are the interesting cases. So what can I do? Well, I'm allowed to give her an X and she gives me a Y, right? If I give her this X value, right, then her goal, she has to say this is true or this is true, right? And this one's already true. So she doesn't have to do anything about beta, right? She can give me that beta. And then I say, well, that was okay. That didn't really help me, right? Because I'm trying to find an alpha that's false or a beta that's true. So I try again. I give her this X. Well, she can keep giving me the same Y, right? I can keep going through these X's and she keeps giving me Y's, right? So is this going to be helpful? Well, it certainly won't be helpful. It's going to take a long time, right? I'm going to have to go through all the X's. In fact, there might be an infinite number of X's, in which case this is really not very useful, right? So I think it's interesting to see. One thing I liked about this is this statement is, though it's, right, it tells us what's going on, it's not useful for us to use as an oracle. And it's also, you say, well, what about the formal proofs? Well, we couldn't get it to work in the formal proofs until we did really kludgy things, right? So she's just not useful to us, right? So what are we going to do instead? Well, our intuition was that it's separable like this. So, and there's a big or here, and big ors, what do they ask for? They ask for proof by cases. So let's do a proof by cases here. Well, our one case is going to be this side here, that all the alphas are true, right? Now, I shouldn't walk too far away from your mic. What is the other case? Yeah, you know, I was tricking you into answering that question, right? Why can't the beta be one be our case? No, because we don't know this or, right? This or is something we think is true. We want to prove is true, but we don't know it's true, right? So we can't have those be our two cases. So what should our other case be? Exactly, right? How do we know that one of these is true? Is either true or false. Remember, it's called excluded middle, right? Everybody see that? Now we have two cases. Either all the alpha is true or there's an alpha that's false, right? All right, so now what are we going to do with these cases? Well, in this case, all the alphas are true, right? So here's the case that all the alphas are true. And she's assuring us. And what is this oracle is a much nicer oracle, right? I can give her any x, and she assures me it's true, right? So it's a more useful oracle. And how are we going to use it? Well, we need to prove this whole thing here, right? Now, what do I have to do? I have to start by coming up with the y, right? How do I come up with the y? What? Yeah, no, because my oracle doesn't give me things, right? My oracle's a Forall oracle. So well, we might be able to turn her, if we had the rule that for all x could turn into there exists an x, then she could give it to us, right? And actually, that's a little funny point that I've never mentioned, and I've been meaning to ask somebody, like ChatGPT or somebody. Here's a question: if for all does for all y imply that there exists a y, right? I want that to be true, right? But when is it not true is when there are no objects at all, right? If there are no objects, then for all y is automatically true, and this one's automatically false. And so in my mind, the way I got around it is let's assume our model always has at least one object. But yeah, it didn't occur to me till right now. If you converted this for all into an exists, then we could use her, right? But what I'm doing instead is I'm just going to throw this away, right? I'm going to throw away the fact that I need to construct a y. And then now I do for all x. And what do I do? How do we do the for all x? Right? The adversary gives me an x. What do I do with my x? Right? I give, oh, well, actually, here's another reason why we don't want to use the oracle for my y is because my y's have to do with betas, right? So if she gave me one, it wouldn't be useful anyway, right? That's why I threw away the beta. I threw away the y. All right, so now the adversary gives me an x. I give it to the oracle, right? And the oracle assures me that alpha is true for it, right? And now what I need to prove is this. I have to prove this or. How do I prove the or? We build. Remember building? We know the alpha is true. And hence, by building, we get that they're both true. Everybody got that? And we're done, right? So if we had this oracle that proved this for all alpha, then we can prove this thing pretty straightforward, right? Does that make sense? All right, so now we have this other case. Now we know that none of the alphas are true, right? So what are we going to do with, we don't like this negation in front, so we turn it into an exists. And what does this oracle do? Right? This oracle assures us that there exists some y, there exists some x here, there exists some alpha that's not true, right? So she can give it to me, right? So I say, hey, now look at from this oracle, I have an x for which alpha is not true, right? Now that's not going to help me with this, the alpha side, right? But how are we going to get the beta side? Right? We get rid of, we don't need this oracle anymore because she gave us this guy down here. We have that already. And now we can go back to our previous oracle. Remember, this was the oracle that we didn't like. This was the oracle. I give her some x, and she's going to, and I don't know which x to give her, right? But now I have an x. I have an x for which alpha is false. So I'm going to give her, I got to give her an x, and which x am I going to give her? I'm going to give her this x for which alpha is false. Now she's going to give me a y. And which y is she going to have to give me? Right? Can she give me 0 like she was doing it before? No. She has to get one of these guys true and the alpha's false, right? So now she's forced to give me a beta that's right. In fact, she gives me some y for which either alpha or beta, right? But we know that the alpha is false, right? So then we get selective or we get the beta. Is that making sense? Are you guys kind of following these? Right? So now she gave, right? So I needed to construct the y. Which y do I construct? Right? So we played this game. Oh, all right. So here I constructed the y. Now he gives me an x, but I don't really care about this x, right? I already have a y which beta is true, right? So he gives me an arbitrary x and I ignore it and I get what I want, right? Everybody follow this game? You see, it's a tricky one, isn't it? Right? The one we skipped wasn't tricky. It was just bang, bang, bang. And there's a video out about it, and you can watch it if you want, but it's really an easy one. All right? So let's do the formal game, right? We're doing deduction. And then here I'm kind of going backwards. You know, you can go either direction, right? You can take what you have here. And right, the problem with going forward is, well, it's a for all x, and I don't quite know who to plug in for x yet, right? So, right, because if you rip off the x, then you can plug in any x you want. But so let's go backwards, right? Let's remove the exist. Let's remove the for all, and now this statement here is kind of Jeff's notations for the same thing, right? It's saying x is a free variable, and this is one specific y, right? So what is it saying? There exists one specific y that works for every x, right? We should be able to translate that into this anyway. All right? And we know we need to do proofs by cases. So here, what are our cases be? We haven't said what our cases are yet, but what we're trying to prove is this line 15 down here, right? So our line 15 are going to use our cases, right? And then what are our cases? Well, we knew what our cases were, right? They're either for all alpha or not for all alpha. So let's do the first case. Here's the case for all alpha. All right, so we had getting from this to this isn't so bad, right? We have for all alpha, we can just rip off the, we're going for an x here, right? So we just rip this off and put in the x. And now we have this and we have to build an OR, right? How do we do that? We build the OR, right? Are people able to follow along? Are we going too fast? Right? We had the alpha so we can get the OR, right? And that gives us what we want. Everybody right? All right, so now let's do the not alpha. How did we do that? Well, we turned it into an exist. And then we ripped off the exist and said, Oracle, give me, how did we do it? We said, Oracle, give me the name of the guy that exists, right? So Oracle says, sure, here, let's call it x sub exists. There's an x for which alpha is false, right? And then what did we do? We went back to this earlier Oracle, right? And this Oracle says, hey, it's true for every x. Oh, then I can say, what about this x? Remember, I didn't want to rip off that x because I didn't know who to plug in, right? But now I know who to plug in, right? I have this guy here. So in this for all, I plug in that object that we got from there, right? I'm basically, this Oracle gave me an x for which is alpha is false, and that was Oracle 2, and I gave it to Oracle 1, right? And what Oracle 1 assures me, yep, my statement's true for that x, right? And then what does she do? She gives me a y to make this all true, right? So she gives me some y, right? I say, give me the y for which is true. Give me a name. Oh, it's called y sub exists, right? So now I have this stuff, right? Alpha, I have an x for which alpha is true. I have, right, she's claiming one of them's true, right? But what do we do? What did we do next in the proof, right? We did selective OR. Remember, we know the alpha is not true, right? Alpha is not true, and hence the beta has to be true, right? That's how we did it in the game proof. Everybody good? All right. Now that we have beta's true, now here, this is a free variable again, right? So what was the Oracle doing for us here? What's happening here is the adversary gave us an arbitrary x. And we said, all right, adversary, you gave us an arbitrary x, but we don't really care about your x because we have the beta already and we can build. Right? Does that make sense? So I think this is sort of an example where, you know, the thinking when we go through the game and we go through the formal proofs, I think they're kind of the same, except, I mean, I'm just saying, if George taught me these rules and didn't teach me anything about communicating between these oracles, I never would have come up with this, right? That's my religion. All right, so any questions about this one here? Yeah?
If this a y instead of y and for all y there's not y, is it gonna be solvable?
Yeah. You know what I mean? If you did this on the betas instead. Yeah, I too said that, and it works. It also works. The reason I did the alphas is it's a slightly cleaner. The beta one, I just did it quickly laying in bed in my head, so don't quote me on it. But my brain and my head got it to work, and it felt a little more cumbersome, and I did this one. But there's a good exercise. Try to plug in, do it with the betas and see if it works, and it does. And this case is, I think I've used the word Davis-Putnam before, but you might not have remembered it. Back when we had just true and false and ands and ors, and I'm trying to build my robot to go out of the room, I need to find a satisfying assignment. And the classic way they did through the 70s and 80s, and maybe they still do, is called Davis-Putnam, where you branch on the value of one of the variables, right? Suppose you know X, P is true, now you know P is false, and you simplify them. So this idea of branching on something is, in fact, those of you who are in 2001 know about recursive backtracking, right? Recursive backtracking is, I say I have a little bird who gives me information. She either tells me all the alpha's true or she tells me all the alpha's false. That's kind of doing a branching on, I don't know how to proceed. And you can branch here on anything you want. And you branch on the one case, and then you branch on the other case, right? So it's proof by cases. When I've taught recursive backtracking, I never did proof by cases. I should throw that in. Right? Is everybody kind of following that? All right. So this is I told you when I was standing outside, we knew we needed to do proof by cases, and then it didn't quite, then I was laying in bed, and it was like, no, it doesn't quite work. And I got up, and I typed this up. And what are we doing? Oh, here's the main issue, all right? This line up here says X is a free variable, and the Y that we get depends on the X, right? Well, what we want to prove is that there's one Y that works for all X, right? So what we're trying to get rid of is the dependence of X on Y, right? Everybody see that that's kind of what this whole problem is. And how do we do it? Well, the reason when we remove this Y, we didn't go over the formal rules very much, but here it's what it says is when you remove this Y, you say, oh, I already have a free variable X, right, in my sentence. And so I have to make Y dependent on X, right? It's because it's tied in with this X. All right, so what we need to do is separate out these two. So here I'm going to prove by cases, and my cases is either this or this. I have two cases. And in this case, it's trivial, right? And then in this case, right? So now I'm in the case assuming this guy here, right? And the funny thing is I still have Y is dependent on X, right? That's when I woke up in the middle of the night saying, oh, I'm doing this cases, but my B is still, my Y is still dependent on X. So then I got out of bed and I thought about it and I said, what am I going to do with this thing here? Well, this is a bit of a kludge. I know I can add the Y, the exists Y back in. And when I do it, I can take the whole thing, right? I mean, it's just, there are no free variables. You know, I can here there's some term for which B is true. So I know there's some Y which B is true, right? So I can go from this line to this line. And then how do I get down to this line? Well, now I can remove the exists again. But when I'm removing it, there's no X involved, right? So I get it without the without the X involvement, right? So there's another, that's the formal proof that I came up with, and it feels very kind of kludgy, and I like the other proof better because, I mean, this feels, well, we're just playing with the rules to make it work. While the other one, well, the other one fits in with my intuition about the game. All right, how's everybody doing? All right. All right, so where are we now? I had some geometry slides, which from an assignment, and on the weekend, I got rid of the assignment part, so I'd like to do those. We're here now, so let's think about the overview. How much time do we have? 20 minutes, 25 minutes, great. That'll be enough to do this review and to do geometry. All right? So what would the next topic be, and we might decide to skip it, is this formal proofs. So let's go through the rules more carefully now, and you should really appreciate them anyway. All right? We can add and remove quantifiers, right? And what is the removing quantifiers? This is right? We know this is true, right? We know for all x. The oracle, we know it, so the oracle is assuring us. And so we can remove the for all. How? We can give her any object we want, and she'll assure it's true for that. So I can take any weird object here. It could be a free variable, right? I could remove this and get that, or I could plug in any weird thing I want. I could plug in alpha, a Jeff if I want, right? I give her Jeff and it's true. Everybody get that? That's what we've been doing, right? All right, how do you add it back in? Well, if we have a free variable, then what's the free variable saying? This is saying that's saying x is an arbitrary object, right? And if I'm saying alpha is true for an arbitrary object, then I can put the for all back in, right? And that's basically, these are two sides of what we were doing in the game, right? The game is oracle assures me for all x, so I give her an x, and then later on, we can get back to the, oh no, this side is, sorry, I take it back. Remove, let's start. How do we do this? Now my goal is to prove for all x, right? How do I prove for all x? I say, adversary, give me an arbitrary x, right? And here's the arbitrary x that my adversary gives me. I prove it for this arbitrary x, and then I can add the for all x back in, right? Does that make sense? I have slides which talk about all of these things, which we can decide whether to go over or not. All right, now we're removing the exists. So this is, again, where the oracle, we know it's true. We know the exists true. The oracle is assuring us of it, right? So if she's assuring us that there exists the y, then we can say, oracle, give it to us. Let y sub exist be the thing that we know exists, stated to exist in the previous line. We give it a name, right? On the other hand, suppose here a y exists. Oh, but we got a free variable, right? And which y exists depends on this free variable. So then we say, yeah, there is a y that exists, but it depends on our x, right? People see these rules, right? And this is the rule that, you're right, this is a change from George. He didn't let you have these, I want to say scrotum, but it's not. It's some guy that sounds like that, but Pleiter. All right, now, and note that exists here. Oh, in this case, the y depends on the x, right? And this just says, hey, if you're going to have different, you need them to be unique, right? Don't use the same name more than once, right? Which is true up here. All right. Now we want to prove it exists. How do you prove it exists? Well, if you prove it for any particular term, any object, you prove object alpha is true for some weird thing like Jeff, then there exists a y for which it's true, right? And this is, how do you prove it exists? You construct somebody, right? I construct Jeff, and I prove alpha is true for Jeff, and then it exists, right? That's how you prove it exists, right? And it doesn't say here up here, but of course, oh no, here it says, right? We have these other weird terms, and you can't do the Forall for these other weird terms, right? Everybody get that? That's what we've been doing so far. And you got your negation rule, right? Clearly we need that. All right, so we've covered all of this, and there's one thing that just hasn't come up in all our discussions, right? And well, first off, you can formalize the fact that you can use a proven theorem and then later use it. But this one is something that early in my days of trying to teach this, I was reading George's book and I was like, I don't get what you're doing here. And that's because I didn't actually read it. I just jumped in the middle of a proof. And George said, no, you're missing this rule. All right. So here's a rule, a formal rule that we haven't actually talked about. All right. It's how do you prove that alpha implies beta, right? You assume alpha and you prove beta, right? But what am I doing with these little weird things, right? This here, this x is a free variable, right? And this x sub arrow, it's not a free variable, right? It's going to be a constant. Now, but it's an arbitrary constant, right? So it's kind of in between. Free variables are arbitrary. Constants are fixed. And what do we got here in the middle? We got this weird thing that's an arbitrary constant, right? What does that mean, right? I think I got it written out here. What am I assuming, right? We're assuming, and we indent, we're assuming alpha is true for some value. Well, when we start the assumption is started with a constant, but it's an arbitrary constant, right? So here, I'm going to assume it's true for some object. And then I'm going to go through the proof, right? And what can I do from this alpha with some object? Well, it's some object, so I can get exists if I want. But this little arrow prevents you from doing Forall, right? Why? Because I haven't assumed Forall x. I've assumed this x, right? I assume this x, and then I prove beta for this x, right? I haven't proved all alpha are true. So I don't want to get this line. Does that make sense? So you can add Foralls, right? All right, so what we do is we start by proving alpha is true for some value of x, right? Whenever, see here, x is free in here, right? So we're wanting to prove free variable gives me free variable, right? But that's just too much, right? So I assume alpha for some value of x. I prove beta. Oh, is it time already? Have we run out of time? We haven't run out of time. How many minutes do we got? 15 minutes. He's just saying hi. Nice to have you with us. All right. So everybody follow that? And then you can prove that this x gives you this alpha is true for this x, beta gives me this x. Now, once we have it back into this form, we've unindented, right? And we know that alpha for an x gives you beta for an x. But which x? Oh, well, remember our proof worked for any x, right? Our proof for any x. So now you can bring the Forall out, right? Now we can see for any x, if you have that true, you're going to have that true, right? Does that make sense? And why do we do this? I have a section of slides called "Things Go Badly Wrong," and if you don't use this rule, things go badly wrong. All right. All right. So we're not going to do it today anyway, but decide whether you want to go through these more of these formal slides. Right. Here's another question. I've been starting to make up our test 2, and so far I don't have a question which says do it formally. So think about, do we want a test question that says do it formally? Do we want not? Or maybe what I could do is I could give you a problem and you could either do it formally or do it by the game. That's another option. So think about what you want to do with formal proofs, and we'll talk about it next class. All right? And then we got 11. Oh, we got lots of time. It's only 7 after. All right? What does this slide say? This says, why do we do abstraction? Right? Why are we doing all these weird things? And the reason we're doing these weird things is because I could say, I want to prove things about bananas, very concrete, right? If bananas are too brown, then I don't want to eat them, but they're sweet from my banana bread, right? I could be very concrete. But by generalizing it and say for all fruit, if it's too brown, I might not want to eat it. Then later on, you can use the same idea for more and more things, right? It becomes useful for lots of different things. Strange objects that you've never seen before, you can prove it's true for, right? I have a set of slides on semantics, but I think we'll skip them because we've done a lot of semantics already. This set of slides on induction, I think it's really good and it will help you in your life. In 2001, there's a lot of things on computing, which these are all things that you will have to do in 2001. These are things that happen a little bit in 2001 and a little bit in 3101. And Gödel's incompleteness theorem, we don't cover it in this degree, but I think everybody should know, right? And then, then what do I have? I have a little machine learning, which is cool, a little number theory, which is cool, right? A little vector first order algebra, linear algebra, which is cool. Those are all useful. All right, we can cover as many of those as we can muster. All right, so now, since I have minutes left, I moved it up here. It used to be down here as a tutorial, and I moved it up here because I made it cleaner. All right? So everybody watch your time to make sure we don't run out of time.